In this example, I want to solve the equation 3 times x to the 2/3 plus 5 times x to the 1/3 minus 2 equals 0. The thing to notice when you start out with this equation is the pattern with these exponents. So when you have an equation where you have a power of x and then half of that power of x, or another way of looking at it is where your first exponent is double this exponent in the middle and then a constant term, you have an equation that we call quadratic in form. So the pattern in here, just comparing it with the standard form for a quadratic equation over here, so ax squared plus bx plus c equals 0, notice how you have x to the first in the middle and then x to the double that exponent in front as your leading term. And that's what we have here. Now the method that I'm presenting for solving these quadratic in form equations is using a u substitution, where we let u equal this expression here that we have in place of x to the first. So where we normally have x to the first in the middle here, what we have in this equation is x to the 1/3. And that's where you're going to get your u substitution. So the plan is to let u equal x to the 1/3. Well, something to notice then is that u squared then u squared would equal x to the 1/3 squared. That's where you get double that exponent. So this is x to the 2/3, 2 times 1/3. So this right here can be written, let me do it this way, as x to the 1/3 squared, right? That's the same as x to the 2/3. So we have 3 times this x to the 1/3 squared, that's your double the exponent, plus 5 times x to the 1/3 on here, minus 2 equals 0. So this becomes 3 times u squared plus 5 times u is replacing x to the 1/3 minus 2. And I know that that's a lot that happened right there. So let me talk about it for just a minute before I go further. So when I changed this x to the 2/3 into x to the 1/3 squared, so I kind of broke off that double the exponent thing here. Now notice, if I cover up these x to the 1/3 with my hand, this looks like a more comfortable, just regular quadratic equation. 3 times something squared plus 5 times that same amount minus 2. So there's a quadratic equation that you've been dealing with maybe for a while. When you uncover this, it looks a bit scary. When you cover it up, it's not so scary. So that's the idea with these u substitutions. The u is a formal way of saying, let me cover up that x to the 1/3. I'm going to worry about x to the 1/3 later. And let me just solve the quadratic side of this equation. So we write it this way to say, let me just focus on solving this thing as a quadratic equation, and then we'll bring back to the x to the 1/3 later on and worry about that part of this. Okay, so we've got a quadratic equation to solve here. It's got a number in front of the squared term, so that's when I've been writing out this AC method where, and again, you can use whatever method you want for factoring. But the way the AC method works is we look for two numbers whose product, so in other words, when you multiply, I don't want to keep writing this wrong. The product is 3 times negative 2 in this case, a times c, so negative 6. Let me draw a line, separate out my scratch work over here. And the sum is the middle coefficient, which in this case is 5. So be real careful with this. It's easy to get these kind of problems wrong. But so we want two numbers where you multiply, you get negative 6. When you add them, you get positive 5. So what if we did positive 6 and negative 1? If I do 6 times negative 1, I get negative 6. If I do 6 plus negative 1, I get positive 5. So that's what's going to work here. So this is where, if you recall, you expand the middle term. Instead of writing plus 5u, you write plus 6u minus 1u. And so that's still equal to 5u, but now this thing has 4 terms and we can factor it by grouping. So you look for greatest common factor among these first 2 terms. We can factor out 3u, and you're left with u plus 2, plus a factor of 2 from the 6u here. In the second 2 terms, we can factor out negative 1, and that's all you can factor out, and you're left with positive u, positive 2. And this is what you need to see. You need to see these 2 factors matching, which is good. That means we can factor out u plus 2, and the other factor will be 3u from this first piece minus 1 equals 0. Again, after you factor, it never hurts to double check. 3u squared minus 1u plus 6u will give me positive 5u minus 2. So this looks good. Now we can set each factor equal to 0. So set u plus 2 equal to 0, and, sorry, it's going to be a little bit cramped over here, 3u minus 1 equals 0. So we get u equals negative 2, or 3u equals 1, so u equals 1/3. These are our 2 options. Okay, but we're not quite done yet. So the u, remember, was a stand-in for x to the 1/3. So this is really x to the 1/3 equals negative 2. And x to the 1/3 equals 1/3. Let me hold off on that. I'm going to stick with this equation for a minute just because of the space here. So if I want to get x by itself, I can raise both sides to the reciprocal exponent. So if this is 1 over 3, if I raise it to the 3rd power, that's 3 over 3, I get just x. And raise this to the 3rd power as well. So that'll give me x to the 1st, which is just x. Negative 2 raised to the 3rd power is negative 8. So there's one solution. Now I need to do that with this other one, u equals 1/3. So same story there. U is a stand-in for x to the 1/3. If it's equal to 1/3, getting that from there, I need to raise both sides to the 3rd power in order to get x to the 1st. So this will give me x to the 1st equals, when you raise a fraction to an exponent, you just raise the top and the bottom to that power. So 1 cubed is 1 over 3 cubed is 27. So the other solution here is 1/27th. Our solution set is negative 8 and 1 over 27. Taking a step back, so the overall process here was to first notice I've got a power of x and then double that power. So this is one that we can solve using one of those u substitutions where you let u equal this middle expression of x, and that allowed us to write this thing as a quadratic equation. Solve that quadratic equation by factoring. Set each factor equal to 0. We solved for u at this point. But now you have to bring back, okay, well, wait a minute. U was just a stand-in for x to the 1/3. This whole time u was covering up x to the 1/3. So that means when I write u equals negative 2, what I mean is x to the 1/3 equals negative 2. And I have to cube both sides to solve for x. And same deal here. When I write u equals 1/3, what I mean is x to the 1/3 equals 1/3, so I need to cube both sides. And that's overall the process there with this fairly complicated equation.